In this video, we'll discuss several special sum formulas. In terms of the sums that we are going to see, very quickly here, they're going to be related to, as we will see, calculating an enclosed area. And the sums are going to involve things like summing from I equals 1 to n of a constant, an I squared, I cubed. These will be things that we frequently encounter. And corresponding to each of these, there's just a nice common formula that we can use. So if you sum from I equals 1 to n of a constant, there is no I here. So you plug in I equals 1, just see plus sign. I equals 2, plus sign. All the way up to I equals n. And so what you're really doing is adding together c n times. So n times c just gives you back the cn. If you sum from I equals 1 to n of I, that would be 1 plus 2 plus 3 all the way up to n, what you will get back is n times n plus 1 over 2. Okay, the sum from I equals 1 to n of I squared, so the sum of the first n squares. 1 squared plus 2 squared plus 3 squared up to n squared, you get the following convenient formula. And if you do the cube, so 1 cubed plus 2 cubed up to n cubed, you get n over n plus 1 over 2, and that should be quantity squared. So note it's very similar to the formula that we have for I, the n over n plus 1 over 2. The only difference is that it's squared. So let's look at a few basic examples. And these are things that we may encounter in the future when evaluating, let's say, definite integrals using the definition. So let's use our special sum formulas to determine the following sum. The first thing I'm going to note is that we can use some of the basic properties that we encountered in the previous video. We can write this as the sum from I equals 1 to n of 2 minus 5 times the sum from I equals 1 to n of I. Very similar in a sense to how we would break up a derivative or how we would break up a limit. We break it up over addition or subtraction and we can pull up constants. So the first sum corresponds to the first special formula we had on the previous slide. Our value of c is 2, and if we add up 2 n times from that first special sum formula, we get back 2n. And in the next sum, the sum from I equals 1 to n of I, that formula from the previous slide was n times n plus 1 over 2. And now all we need to do is just simplify. So we notice in the second term we have a fraction with denominator 2, so we can write the first term as 4n over 2. And what we have from the numerator of the second term is, if you think n times n plus 1, that would be n squared plus n. So the minus 5n squared minus 5n. And that leaves us with minus 5n squared minus n all over 2. All right, so let's look at a second example. Let's evaluate the sum of 1 squared plus 2 squared plus 3 squared all the way up to plus k squared. So the first step for us in this problem is to rewrite this as a sum. So we're summing I equals something to something, and notice what we're adding up here, terms of the form 1 squared, 2 squared, 3 squared. So in general, I'd say we're summing up I squared. We're going from 1 as our starting point, and we're going to 10 as our finish point. So 10 is going to be the upper index. So if we compare to the formula we saw on the previous slide, if we sum from I equals 1 to n of I squared, we get the quantity n times n plus 1 times 2n plus 1 all over 6. And in our case, the value for n is 10. So if we substitute in n equals 10, we get 10 times 10 plus 1 times 2 times 10 plus 1, all divided by 6. So that's 10 times 11 times 21 over 6, and that simplifies down to just being the number 385. All right, one more similar example. So the first step towards evaluating this, much like the first, is to break it up. We can break a sum up over subtraction. So this is a sum from k equals 1 to 10 of k cubed minus the sum from k equals 1 to 10 of k squared. And let me once again remind you of some of our previous formulas. If we had the sum from I equals 1 to n of I squared, this was n times n plus 1 times 2n plus 1 over 6. And we had the formula, the sum from I equals 1 to n of I cubed is the quantity n times n plus 1 over 2 squared. So the first sum, we can use the formula for I cubed, except instead of an n, we are plugging in a 10. So this would be the quantity 10 times 10 plus 1, so 11, all over 2 squared. And then we subtract away the sum from k equals 1 to 10 of k squared. But if you look back at our previous example, that was the sum that we calculated. So this is just 385, and that is from the previous example. And if we go ahead and evaluate this, it would be 3,025 minus 385, which is 2,640.